This is the red blood cell analysis section of LabSmarts where we uncovered these findings. So we first determine the likelihood of anemia, and we do this using red blood cells, hemoglobin, and hematocrit. And in this case, it looks like she was highly likely to have suboptimal blood oxygen delivery, anemia. The way you say that in the terms of these three markers would be, it's highly likely that the delivery of oxygen by the red blood cells to all cells of the body is suboptimal as a result of a lower than optimal number of red blood cells, those are the RBCs, a lower than optimal amount of hemoglobin in a liter of blood, that's what hemoglobin represents, and a lower than optimal percent of red blood cells in a liter of blood, that's what hematocrit represents. Next, we determine the type of anemia. So we first use MCV to determine the red blood cell size, and in this case, her red blood cell size were small, microcytic. Next, we use MCHC, mean corpuscular hemoglobin concentration, to determine the red blood cell color. That represents the amount of iron inside the red blood cell based on its size. And in this case, it was pale colored. That represents the term hypochromic. To say this in a sentence would be, the delivery of oxygen by the red blood cells to all cells of the body is suboptimal as a result of smaller than optimal red blood cells, microcytic, containing a lower than optimal amount of hemoglobin for their size, hypochromic. Now, this is the cool part. So we take it a step further and we look at a bunch of different markers and patterns to determine the possible root causes of anemia. And in this case, this is just an example because I always test the iron panel with ferritin, but in this case, if you didn't have the iron panel with ferritin, there would be multiple root causes of microcytic hypochromic anemia. It's not always just iron insufficiency. This is why we never recommend iron supplements for this type of anemia without knowing the iron panel values. So in this case, we did have the iron panel markers because I always order these iron panel markers for my clients. Having those values narrowed down all those possible root causes to just this one here, heme synthesis dysfunction, possibly caused by vitamin B6 insufficiency. So the first part of that, heme synthesis dysfunction, was identified using these four markers. So we can see here that the amount of iron in the serum is more than optimal, and you can tell that the transferrin in the serum that carries around the iron is highly saturated with iron. So there's not a problem of iron deficiency. Also, the amount of iron in storage form in ferritin is more than optimal. So there's definitely not an issue with iron intake here. Instead, there's enough iron, more than enough iron, but it's not being able to be converted into heme to make hemoglobin. And the next part of this root cause is caused by vitamin B6 insufficiency, and we can tell that with these two markers, AST and ALT. Those liver markers are B6 dependent enzymes. When those are less than optimal, it's usually that there's not enough B6 to make those enzymes. Based on all these patterns, the software automatically narrows down the possible root causes for you very quickly to tell you that in this case, the possible root cause that we uncovered earlier was that heme synthesis dysfunction, possibly caused by vitamin B6 insufficiency, sideroblastic anemia.